Have you ever wondered how Docker containers work? Well, today you are in for a treat. Docker is a powerful tool that's shaking up the tech world. It's designed to simplify the process of creating, deploying, and running applications by using something called containers. Picture this. You're a developer who's just created a brilliant new app. Now you need to package this app with all its parts, such as libraries and other dependencies, and ship it out as one neat package. This is where Docker steps in, providing a smooth route for your app from development to delivery. In essence, Docker is a bit like a virtual machine. But unlike a virtual machine, rather than creating a whole virtual operating system, Docker allows applications to use the same Linux kernel as the system that they're running on, and only requires applications be shipped with things not already running on the host computer. This gives a significant performance boost and reduces the size of the application. Now that we know what Docker is, how does it work? Docker operates through its engine, a runtime that runs the containers. Think of this engine as the heart of Docker, pumping life into the system. It's responsible for creating, running, and managing containers. It's a lightweight, standalone executable package that includes everything needed to run a piece of software, including the code, a runtime, libraries, environment variables, and config files. Next, let's talk about Docker images. They are read-only templates used to create containers. An image is a lightweight, standalone executable package that includes everything needed to run a piece of software. It's like a blueprint that Docker uses to build containers. You can create your own images or use those created by others and shared in the Docker Hub. Now, what are Docker containers? In simple terms, a Docker container is a runnable instance of an image. You can start, stop, move, or delete a container using the Docker API or CLI. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. Let's move on to Docker files. These are sets of instructions describing how to build a Docker image. They are easy to understand, and they automate the repetitive tasks of installing and configuring software. Docker files start with defining a base image and a set of instructions such as installing a certain application, defining environment variables, and running certain commands. Finally, we have Docker Compose. It's a tool for defining and managing multi-container Docker applications. With Compose, you use a YAML file to configure your application's services, and then with a single command, you create and start all the services from your configuration. So, Docker uses the container model to bundle an application along with all its related configuration files, libraries, and dependencies required to run in an efficient and bug-free way across different computing environments. You might be wondering, why should one use Docker containers? Well, there are several compelling reasons. Docker containers allow for rapid application deployment. This means less downtime and more productivity. They offer portability across machines, making it simple to move and replicate work environments. With Docker, you can work on your local machine, then seamlessly deploy to the cloud or another system. Docker also supports version control and component reuse. This means you can track changes, roll back if needed, and reuse components across projects, saving you time and effort. Docker containers are designed to share resources, making them incredibly lightweight. They don't carry the extra load of a full operating system, leading to a smaller footprint and faster performance. And let's not forget simplified maintenance. Docker containers make it easier to manage and update applications, reducing the burden of maintaining your software. In short, Docker containers can help solve many problems of software development by creating a unified, collaborative, and streamlined platform for building and running applications. Let's recap what we've learned about Docker containers. At their core, Docker containers are lightweight, standalone, and executable software packages. They encompass everything needed to run an application: the code, runtime, system tools, system libraries, and settings. This ensures consistency across multiple environments, making Docker containers incredibly versatile. We've also discussed how Docker containers function. They use the host operating system, isolating the application processes to avoid conflicts. This means you can run multiple containers simultaneously on a single host, each with its own set of processes, network interface, and file system. And let's not forget the advantages. Docker containers simplify software delivery by bundling applications and their dependencies into a single object. This facilitates fast, reliable, and repeatable deployments regardless of the environment. And there you have it. Docker Containers Demystified. So, next time you're developing an application, why not give Docker a try?